Top of the day to you Algebra 2 students. This is Mr. Hotard here. Today's lesson is going to be on graphing the vertex form of quadratic functions. We're going to be doing this without a graphing calculator. All right, but don't worry, it'll be okay. All right, so we're going to start our lesson now. As Mr. Arnold from the first Jurassic Park movie used to say, that is before he was eaten by the velociraptor, hang on to your butts. Okay, three things we'll be able to do with these quadratic functions. First of all, we're going to identify what the transformations are on the parent function of the quadratic function. We're going to be using those transformations to graph the quadratic function. And then last, we're going to take a quadratic function, apply some transformations to it, create a new quadratic function. All good stuff. Now, this lesson today should look mostly familiar. A lot of it is just a review of what we did at the very beginning of the year with transformations of functions. The same holds true with these quadratic functions. Now, what is a quadratic function? Remember, a quadratic function has to have a 2 exponent in the problem, like an x squared. And do you remember what shape it makes when you graph it? A U shape, a parabola. Okay, so let's just start by reviewing our transformations. You could have a number in A, H, and K. By the way, we call this the vertex form of quadratic functions. There are other forms we're going to study later, all right, but this one's called the vertex form. It's the easiest one to graph by hand because you can just look at the problem and tell where the vertex is. So first of all, the A value, the number in front, all right, if it's positive, it's still a U-shape, it's going to open up. Opens up. It would look like that. What happens if you have a negative in the front? It opens down. Like that. Now, that A value, sometimes you have a number here. If there's no number, it's an automatic what? It's an automatic 1. But if you have a whole number, 2, 3, 4, all right, we remember that is a vertical stretch. It makes the graph narrower. And if it's a fraction, 1/2, 2/3, something like that, that would be a vertical shrink. It would make the graph wider. Okay, now, this is generally true. However, there are some exceptions. Remember, there are some fractions that could actually stretch it. That would be like 4/3, 9/5, something like that. So basically, if the number in front is bigger than 1, it stretches it. If it's smaller than 1, it shrinks it. Now, these numbers, H and K, remember the number inside the parentheses, which way does that move it? Moves it left and right, all right? But this one, it does the opposite of what it looks like it should do because the formula already has a minus in it. So if you have x plus a number, x plus 5, that's going to shift it to the left. And if you have x minus something, x minus 3, that would shift the graph to the right. It does the opposite of what it seems like it should do because the formula already has a minus in it. And then the number at the end, that's the easy one. All right, that moves it up and down. Plus, it's going to shift it up. Shift, I can spell shift. Shift it up, and minus is going to shift it down. All right, so numbers at the end move it up and down. Numbers inside the parentheses move it left and right. Numbers in the front, if it's a negative, it flips it across the x-axis, and then numbers, whole numbers are going to stretch it, fractions are going to shrink it. So let's use these transformations to actually graph some problems. If you look at the first one, x squared minus 3, that minus 3 at the end is going to move the graph which way? It's going to shift it down 3. That's my only transformation. So to graph this, my vertex, I'm just going to, instead of starting at 0, 0, I'm going to go down 1, 2, 3. There's my vertex, the tip of the U. Now to finish the graph, if you look in front of x squared, there's no number there. It means there's an automatic what? It's an automatic 1. All right, there's a 1, so I can go from this point, I can go up 1 over 1. That number in front of the x squared tells you the slope of the graph as you move right and left 1 unit. Now don't keep going up 1 over 1. It's not a V shape, it's a U shape. It's going to curve. All right, but that gives you, that's enough information to give you just a general quick sketch. All right, so now we're going to skip around a little bit. I want you to skip down to the bottom. All right, negative x minus 2 squared plus 1. First of all, this negative in the front, what's that going to do? It's going to flip it, or it's going to be an x-axis reflection. So I know this graph's going to be open and down. Which way does minus 2 in the parentheses move it? Going to move it to the right 2. And then plus 1 at the end, going to do what? Going to shift it up 1. So first of all, my vertex, instead of starting at 0, 0, I'm looking at the h and k values. So I'm going to go to the right 2, up 1. So to the right 2, up 1. There's my vertex. There's the tip of the U. Now, this time, look in front of the x. There's just a negative, and then it's an automatic 1. So from this point, I'm going to go down 1 over 1. All right, if that had been a negative 3 in front, then I would have gone down 3 over 1. All right, you're just following that slope. And then don't keep going down 1 over 1. It curves. It's a U shape. But there's my quick sketch of my parabola. Let's do one more together. All right, over here on the right-hand side, let's do the middle problem. F of x equals 1/3 x plus 2 squared plus 1. Now, first of all, that fraction in the front, all right, remember, what's a fraction going to do? It's going to shrink it. We have a vertical shrink of 1/3. Which way does the plus 2 in parentheses move it? Left 2, and then plus 1 at the end, going to move it up 1. So let's just start with our vertex. Instead of starting at 0, 0, let's go to the left 2, up 1. There's my vertex. There's no negative in the front, so I know it's opening up. Now, this is the part that's going to confuse some people. All right, there's a 1/3. That does not mean go up 1 over 3. All right, if this were linear, then sure, you could do that. But quadratic, this number in front of x only tells you the slope as you go to the left and right 1 unit. So that means from this vertex, I'm going to go up 1/3 of the block over 1. So up 1/3, just a little bit under halfway, to the right 1 and to the left 1. All right, so that your points aren't going to be directly on the lines here. All right, so that's going to make my graph open a little wider than the others. So now, I want you to pause the video, go back, answer these other 3 problems, and then unpause it when you're ready to check your answer. Did you do it? I hope so. So now let's look at these answers. All right, the second problem on the left, that plus 2 should move it to the left 2. All right, so I'm going to go to left 2 there, negative 2, 0 is my vertex. No number in front of x, so just go up 1 over 1. Over here on the right side, this one, there's a negative in front, there's a 2, so the negative is an x-axis reflection. The 2 is a vertical stretch of 2. So where's the vertex? It's at 0, 0. All right, there were no h and k values. There's no shifting left, down, up, right, anything like that. So it starts at 0, 0. Then from there, you're going to go down 2 over 1. You're always going over 1, to the right and left 1, when you're drawing these quick graphs. And then the last one is probably the hardest one. All right, we've got a negative, which is a reflection. We have a fraction right there, so vertical shrink of 1/2. It's shifting to the right 1. It's shifting up 4. Okay, so my vertex going to be over here. Go to the right 1, up 4, up here. And then from there, negative 1/2. That means I'm going to go down 1/2 over 1, both directions. So that's going to make that graph open a little wider than most of the others. Okay, so that's graphing the quadratic form. The last thing we're going to look at is applying the rules for transformation. So if I already have a function like this, f of x equals 3x squared minus 4. I'm not going to graph it, I'm just going to do these things to it. If I took that and I performed a vertical stretch of 2, all right, now there's already a 3 on here. Okay, so if I'm applying a vertical stretch of 2 to that, I would have to distribute that 2 to this problem. 3x squared minus 4, I'd have to distribute that 2 to everything here. So what would that become? It becomes 6x squared minus 8. All right, now we're not done because we also have to shift it up 1. So I need a plus 1. Now there's already a number at the end. So what would I have to do with that negative 8? I'd have to add 1 onto it. So my answer here would now be, I'll just write g of x, just to say it's a new function. That doesn't really matter. Equals 6x squared minus 7. Negative 8 plus 1. One more problem. Using that same function, 3x squared minus 4. This time I want to perform a horizontal stretch of 2 and then shift it to the left 1. So the horizontal stretch, remember, this is the one that you flip. You don't actually put a 2 in the formula, you're putting a 1/2. All right, and that's going in the parentheses directly on the x. So if I rewrite this, if I add parentheses in here, I have 3 parentheses. Right now, there's just an understood parentheses. It's not written. But if I put that 1/2 on that x, squared minus 4. All right, I have that. And then I want to, from there, I want to shift it to the left 1. Now, don't try to multiply the 3 and the 1/2, all right, because of that squared. This is actually 1/2 squared. So I'm just going to shift it to the left 1. That means plus 1 or a minus 1. That's a plus 1, and does it go at the end or in parentheses? In the parentheses. So I'm just putting a plus 1 right there. So my final answer, g of x, is going to be 3 parentheses 1/2 x plus 1 squared minus 4. The end.